Hey everyone, Teacher Chang here today, and today we're going to be using the Pythagorean Theorem and the distance formula to determine the distance between 2 points on a coordinate plane. We're going to go ahead and take a look at when we might use the Pythagorean Theorem over the distance formula and vice versa. So let's go ahead and start off by looking at how we would use the Pythagorean Theorem to go ahead and calculate the distance between 2 points. So let's take a look at this first one. It says that to find the distance of the line with the coordinates A, 1, 2, and B at 4, 5. So let's go ahead and start off by plotting those 2 points. So A is located right over here at 1, 2. And B is located at 4, 5, which is located right over here. And our goal is to figure out, okay, well, what is the distance between these 2 points? So I'm going to go ahead and take my straight edge, and I'm just going to draw this line between A and B. And what we want to do is we want to go ahead and figure out, okay, what is the distance between A and B? Now, a lot of people might mistake that and say, oh, it's 3 units long, but it's not because it's at an angle. So anytime we have a line at an angle, we can't count how many spaces we have in between them. So what we're going to do is we're going to use the Pythagorean Theorem. And remember, the Pythagorean Theorem only works for right triangles. So we said that earlier in the past, that Pythagorean Theorem only works for right triangles. So what we're going to do is we're going to draw a right triangle. So I'm going to take my straight edge out again, and I'm going to draw horizontal and vertical lines so that we create a right triangle, and making that line segment AB that we drew earlier as the hypotenuse. So I'm drawing these horizontal and vertical lines until they meet, and when they meet up, it's going to create that right angle. And once we create that right angle, we now have a right triangle. So this right triangle is going to tell us that the hypotenuse is going to be that line segment AB. So there's our hypotenuse. Now we want to go ahead and figure out, okay, well, what is the length of each of our sides? Now remember, the hypotenuse is always the C value. So this is our C value. That means A and B are the 2 other sides. Well, if we count how many units they are, because they're horizontal and vertical, we can count them. A is going to be 3 units long, and B is going to be 3 units long. So now that we know what A, B, and C are, we're just going to substitute everything into our Pythagorean theorem, which is A squared plus B squared is equal to C squared. Well, again, we know that A and B are both 3. And remember, when we substitute, you're supposed to put it in parentheses, is now equal to C squared. And we don't know what C is, so we're just going to leave that as C squared. Well, if we do the math here, well, 3 squared is obviously 9. So now we got 9 plus 9 is equal to C squared. And well, 9 plus 9 is going to give us 18. So now we got C squared is equal to 18. Now we have one last step, is we got to get rid of that square because we want C, not C squared. And that way the squares will cancel out. The square and the square root will cancel out. And C, if we do the square root of 18, that's going to be approximately 4.24, or we'll say 4.2. So it's approximately 4.2 units. All right, so that's the Pythagorean theorem. Now let's go ahead and take a look at when we might use the distance formula. Now the distance formula is when we don't have that coordinate plane. They told us to go ahead and find the distance between 4, 1 and -2, 0, but we don't have it on that coordinate plane, so we can't draw the right triangle. So that's when the distance formula will come into play. So this is the formula that you guys want to memorize. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that x1 and that y1 and that x2 and that y2, they're going to be the points that we're trying to find out the distance between. So in this particular case, we have A being at 4, 1, so that's going to be my first point, so x1 and y1, and B is my second point, so that's going to be my x2 and my y2. Now, all we got to do is substitute everything into our formula. So D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm just going to fill in those spots. So in this particular case, our x2 is going to be -2 minus x1, which is 4, plus we have our y2, which is 0, minus y1, which is 1. And all of those are squared. So now let's just go ahead and put all of this together. So if we take a look at this, negative 2 minus 4 is negative 6. I'll write that down, so negative 6 squared. And then 0 minus 1 is negative 1, so negative 1 squared. And all of this is still underneath that square root. And then we'll just square each one of these. Negative 6 squared means negative 6 times negative 6, so that's 36. And negative 1 squared is negative 1 times negative 1, so that's positive 1, so that's 36 plus 1, still underneath the square root. And then, well, 36 plus 1 is 37. And now we just need to figure out, okay, well, what is the square root of 37? You type that into your calculator. You get about 6.08. And if I were to round it to the nearest tenth, that means it's about 6.1 units. So that's when we would use the distance formula. So Pythagorean theorem is when we have it on a grid, a coordinate plane, we could draw a right triangle, and then we could use the Pythagorean theorem. And if we can't draw that right triangle, if we don't have the coordinate plane, then we could go ahead and calculate it by using the distance formula. So let's go ahead and apply it by finding out the perimeter of this triangle. And I'm going to go ahead and use both methods. I'm going to start off by doing our distance formula first. And I'm going to start off by figuring out what is the distance of A to B. So that's our first side over here. So perimeter means to find out the length of every side, and we're going to add them together. So I'm going to start off with side AB. And that's going to be our first side. Side AB is going to be side 1. So I'm going to go ahead and organize my thoughts. And since I'm using the distance formula, I know that point A is going to be at 3, 5. And point B is going to be at 0, negative 4. And that's going to be my x1 and my y1 for my first point. My x2, my x1 and my y1 for my first point. And x2 and y2 for my second point. Now remember, the formula is d, which is our distance, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And all we got to do is substitute everything in. So I'm going to go ahead and keep my parentheses, my minus sign, my square, and same thing on the y's. And all we're going to do is substitute everything in. Okay, x2 in this particular case is 0. x1 is 3. And then we have our y2, which is negative 4, and y1 is 5. All we did is substitute, and now we're going to solve. So if we solve this, 0 minus 3 is negative 3, and negative 3 squared is going to give me 9. And then we have plus negative 4 plus 5 is, negative 4 minus 5 is negative 9, and negative 9 squared is going to give me 81. So now I got 9 plus 81. And 9 plus 81 is 90, so now we got the square root of 90. And if you type that into your calculator, that's approximately 9.5. So there's our first side, 9.5. Now our second side, I'm going to actually do the Pythagorean theorem method. So now let's go ahead and take a look at our second side, and let's go ahead and do side BC. So BC is located right over here, and I'm going to use the Pythagorean theorem method in order to calculate this. And the reason why I can use the Pythagorean theorem method is because I can go ahead and draw my right triangle. So I'll take out my straight edge, I'll draw a vertical line going straight down, and a horizontal line going left and right until the two lines meet, and that's going to create my right triangle. So here's my right angle right over here. Okay, so there's my right angle. So what we want to do is we want to go ahead and figure out, okay, well, what is this length over here? And that's going to be our a squared plus b squared equals c squared. Okay, so in this particular case, I need to figure out, well, what is a and what is b? Well, a is going to be the distance of one of these sides, and that's going to be 4 over here. And the b is going to be the distance of the other side, and that's going to be 7. So I got a 4 by 7 here. So a is 4, so 4 squared. B is 7, so 7 squared is equal to c squared. Well, 4 squared is going to give me 16. And b squared is going to give me 49. And 16 plus 49 is going to give me 65. So that means I need to take the square root of 65 to cancel out the square, and that's going to tell me what c is. And c, square root of 65, is going to be approximately 8.1. So now I figured out the distance of side 2, and that distance is for side BC. All right, last but not least is my third side, and the third side that we want here is going to be AC or CA. And it doesn't matter which way you go because the distance from C to A is the same distance from A to C. So let's go ahead and make a little bit of space here. I'm going to move this down a bit, and I'm going to go ahead and try to do the Pythagorean theorem once again over here. So I'm going to try to fit all this in over here. So let's do side AC, and we're going to do the Pythagorean theorem once again. So I'm going to create that right triangle by drawing a horizontal line and vertical lines until the two lines meet, and that's going to create my right triangle. And when I do this, we could see that on one side, the one that's going up and down, this is going to be 2 units long, and the other side going left and right, that's going to be about 7 units long, and that's going to be my A and my B. So that means I'm going to do 2 squared plus 7 squared is going to equal to C squared. Well, 2 squared is 4, 7 squared is 49. That's all equal to C squared. 4 plus 49, that's going to give me 53. Is equal to C squared. And once again, we just need to square root it on both sides. And that way the square and the square root will cancel out, giving us C to be approximately 7.3. You could type that into your calculator. So now we got 7.3. So now what we're going to do to find out our perimeter is we're going to take all 3 of these sides and we're going to add them together. So we're going to go ahead and take the 9.5. We're going to add that with our 8.1. And we're going to add that with our 7.3. So we'll add these together, and that's going to give us our total perimeter, and that's going to be approximately 24.9. So we can see that our perimeter of this triangle is going to be approximately 24.9 units. All right, that's how you go ahead and use the distance formula and Pythagorean theorem to find out the distance between 2 points and how we can apply it to something like the perimeter of a triangle or any other polygon that might be on a coordinate plane. I hope this helped out. If you have any questions, go ahead and leave a comment. If you liked it, give me a thumbs up, and don't forget to subscribe. All right, good luck, enjoy, and have fun.